Hey everybody, how y'all doing? What I wanted to talk to you about today are further reactions after the conjugate addition. Because remember, when you have this enolate, this is your addition adduct. All right? Now this enolate right here is just an enolate, meaning it can do anything else that an enolate can. So we're talking halogenation. Now, I'll be honest with you, I don't never seen anyone do it. I don't know why you would, but it's an option if you want it. 2, alkylation. 3, aldol addition. And possibly condensation. 4, Claisium. And finally, here, the last one here being another conjugate addition. So let's take a look at these in order. I'm going to jump right to the adduct after you've added your enolate down there. So now we're here. Let's introduce this, say, to 1-bromopentane. The alkylation would simply do this. Remember, it is an SN2, so you need primary or methyl alkyl halides in order to do this well. And you would get this. And you'll notice in this situation, there is no other atom that needs a proton. All is well here. Okay? Now, this could be just about anything if you really want it to. What if instead of, so this would be the alkylation. Let's do a aldol reaction. So now we have our addition adduct. Here. And now we're going to bring in a molecule I will regret using because it's going to be very big. Acetophenone. All right. Reform the pi bond. Attack. Open. And you are here. All right. So now that we're there, we can add the proton, and we would get this. And then finally, if we really wanted to, we can push this to the aldol condensate, which in turn would look like this. And that is your product. All right, so that is an alkylation. This is a aldol What about ecclesian? Easy peasy. Now, to show you this will work with almost any addition product, I'm going to use this one, which was made by reacting the alpha beta unsaturated ketone with that, the Gilman reagent. Now this would just attack there, blah, blah, and take us up to where we are. Now, we want to do ecclesian. What's the difference between ecclesian and an aldol? Answer. In an aldol, you're using a ketone or an aldehyde. In ecclesian, you are using an ester. So let's bring this in with, our old friend, ethyl acetate. What'll happen here is you reform the pi bond. You do a nucleophilic attack. Pi bond opens, pi bond closes. That group leaves, and you are here. And there are ketones everywhere in this molecule. Okay? Now, we've done ecclesian, we've done an aldol, we've done alkylation. What remains? What could we do? Well, we could do another conjugate addition. Which involves this. We'll go with the Gilman adding product again. And so we've got this. And once again, until you add a protic source, water, alcohol, or acid, it's going to stay as an enolate. So now we do this. And we're here. And this is your conjugate product. Now, you've got a couple options here, so I'm going to come back to this one in a couple of minutes. But the most obvious thing you can do is add some proton. And then you go to this. Again, little ketones everywhere. Now, though, there's a difference in the product. So let's take a look. What you can do is we need to think about what happens if we add another base. Now, this is where it can get really sticky, ladies and gentlemen, when we add another base here, because there are 1, 2, 3, 4, 5, 6 spots for enolate formation. Now, this is just going to turn into a big, ugly mess, ladies and gentlemen. I'm here to tell you. Because here's what I want to do, and I'm going to try using different colors in it. What we're going to look at is an aldol cyclization, and what are our options for an aldol cyclization. So for that, I'm going to just redraw this over here. All right, let's take a look at this. Let's say this is where we form our aldol. Well, this is 1, 2, 3, 4, 5, 6 carbons there. So you could do an aldol cyclization there. You can't really go down because if that's 5, this is 6, 7, and 8. Not the best idea. What about from down here? Could this do some sort, let's say our anion forms there. Could this do some sort of strange alkylation? Well, let's count it. 1, 2, 3, 4, 4, 5, 6. Yikes. That could actually also work. But I want to present to you that for this one to work, you're going to have to get into some very strange geometries because of that big addition adduct up there. So I think, hopefully you can see that the best one we're going to get out of this is in the yellow. Are there others? Yes, but again, some of that strange geometry is going to become an issue. So let's take a look if we do with the yellow. Now, let's do this. And yikes, I'm almost out of time. Which puts us here. Ultimately, we add some acid and water, and we land here. And there's your product. Could this go on and be even nuttier? Why, of course it could. I mean, what happens if we try to do this? 1, 2, 3, whoops. 3. It won't let me write a fucking 3. 3, 4, 5, 6. So we could introduce another base in here, and we could have a secondary cyclization that could occur. I'm not going to show you that because I want to wrap up with this thought. Sometimes these conjugate additions can just be messy. All right? So what you need to remember is when I ask questions, I ask for the major organic product. I won't ask for all possible products because, dear God in heaven, that is a lot. All right, so that brings us to the end of our review of the carbonyl chapter. Monday, we start on aromatics and aromatic substitution reactions. So I'll see you all then.